Hello Geometry B, and welcome to 6.3, Test for Parallelograms. I have two notes. First off, you want to pull out your homework 6.2. I'm going to show you the answers for those. You can double check that and then send me any questions if you want. And you want to print the new note sheet if you haven't already. I sent you an email and have a note on the portal. The note sheet that I gave you in class yesterday will not be used. There's some examples we're not doing, so please pause this video now, get out your notes on homework 6.2 and your test for parallelogram. I'll join you in just a minute. All right, here's the homework from 6.2. That's page 403, number 1 through 5 all, 8 through 20 all, and number 23. I'll be scanning through these quickly, so at any point if you need to, pause the video and double check your answers. For proof number 8, this is actually 4 steps. In step 1, I have my given. In step 2, I use the fact that my opposite angles in a parallelogram are congruent to each other. In step 3, I have my vertical angles, so in the middle there I've highlighted those angles that meet at vertex C. Those are going to be congruent to each other because of vertical angles. And then I can say that A and F are congruent to each other by transitive property. Substitution would also work. Here's the rest of the problems. Again, I'm going to continue on. If you'd like to stop for a minute to double check yours, please pause the video. And here is your second proof, number 23. Very similar to the one we did in class. Again, I have opposite sides WX is congruent to VT, and ZY is also congruent to that same side VT. So therefore, WX and YZ or ZY are congruent to each other by the transitive property. Make sure your work is shown for the rest of your answers. I've just displayed the answers, but not the full solutions. If you have any questions, send me an email. I'll be available this morning and periodically checking throughout the day. All right, moving back to section 6.3, and pause the video if you need to. Make sure you have the new note sheet printed for 6.3. I will be using that new note sheet. You will not match mine if you do not have the new note sheet printed and have thrown out the one that I gave you in class on Tuesday. We're going to work on classifying quadrilaterals today. And specifically, we're going to be talking about that parallelogram, which is a type of quadrilateral. Quadrilaterals, as we said, are four-sided polygons. We're going to demonstrate whether or not a quadrilateral is a polygon, use the conditions of parallelograms to prove relationships in real-world situations, and use the conditions of parallelograms to solve for the values that will make a quadrilateral a parallelogram. Throughout this video, I will be suggesting at times that you pause the video, try and answer on your own. If you don't pause the video, I'll be going immediately to the answer. All right, we'll start with our theorems that we're going to use. Theorem 6.9 says if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So if I have a diagram that looks like this, that pair and this pair are congruent, it is a parallelogram. I do suggest you add the diagrams to your picture. If both pairs of opposite angles are congruent, so opposite sides can be congruent, or both pairs of opposite angles are congruent, then it's a parallelogram. So again, that pair of opposite angles and my acute angles would also be congruent to each other. Then I have a parallelogram. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Perhaps you recall, are the diagonals of a parallelogram congruent to each other? Think about that for a second. I tried to draw this one where it was pretty clear that they're not necessarily congruent. In this drawing, that one I just marked is longer. This is my shorter diagonal. So they are not necessarily congruent to each other, but they do bisect each other. And last but not least, and this is the most interesting one, instead of talking about both pairs of anything, I'm just going to talk about one pair of sides. One pair of sides of a quadrilateral is both parallel and congruent. Both parallel and congruent, then it's a parallelogram. So in the case of my drawing, and I'll make this one a little bigger, if I know that that pair of sides is both congruent and parallel, that quadrilateral is a parallelogram. Things that don't work, if I have this pair of opposite sides are congruent, and these sides are parallel, that won't work. I need to know both things. So we have 4 examples here of parallelograms. The first one's a little tricky. I'm going to work that one with you a little quickly, and then I'll let you pause the video and see if you can answer whether 2, 3, and 4 are a parallelogram from the information given. All right, so I'm going to tell you that number 1 is a parallelogram, and I know that because the opposite sides are congruent. One pair of opposite sides, 14 inches and 14 inches. I don't have anything about the lengths of the other sides. So if I have one pair of sides is congruent, I'd also need to prove that that pair of sides are parallel to each other. And I actually can. Do you see that C shape there? Those are consecutive interior angles. So that does mean that FG is parallel to GH because those consecutive anterior angles, angle G plus angle H equals 180 degrees, or those interior angles are supplementary. Go ahead and pause the video. I will continue and show you the rest of the notes from 1 on what you would need and the answers to 2, 3, and 4. Make sure you include an explanation in yours. Again, you want to pause the video because I am going to the answers now. All right, so looking at our example here, number 2 is a parallelogram, 3 is a parallelogram, but 4 does not have enough information. Just a note on why. Number 2, both pairs of opposite sides are congruent. Oops, sorry, that's cutting off your video there a little. Number 3, opposite sides are congruent and parallel, one pair of opposite sides. Both congruent and parallel. Number 4 does not give us enough information. We just need more than that to prove it's a parallelogram. I would either need that those sides are parallel, or I could do it by saying the other pair of sides are congruent. But with what I have, I don't have enough information. Moving on to our next example. So we have a picture of a tackle box here. If you fish, you've probably seen one of these before. If someone in your family does, my father fishes. And when I was younger and used to go out fishing with him, I love playing with the tackle box. I don't know if you've ever opened or closed them, but those sides right here never end up tilting. They always end up staying parallel with the ground so your lures don't fall out. We can actually prove that using parallelograms to prove why those will always stay that way. And we improve that because PQ is congruent to or equal to the length of RS, and PR is congruent to QS. So why would that make those top and middle trays always remain parallel? Pause your video now, think about that for a little. I'll come back with a full explanation on it in just a minute. So PQRS is a parallelogram because both pairs of opposite sides are congruent. So what does that have to do with the sides remaining parallel? Well, think about your definition of a parallelogram. The opposite sides will always be parallel. It means it doesn't matter how much I shift that or how much I change angle P and S, and angle Q and angle R. The shelves will always remain parallel to each other. You're welcome to pause the video if you want to write down this full explanation. I am going to move on to our next examples, example 3 using algebra. All right. Example 3, use parallelograms in algebra to solve for values. So in this first one, if you look at that, we're going to use one of our theorems. So theorem 610 says that opposite angles of a parallelogram are congruent to each other. Opposite angles. If those opposite angles are congruent, then it is a parallelogram. So if I want to solve for an x or y to make that true, I want to set those equal to each other and find the x that would make it those two angles congruent. Or when does 7x equal 56? The same will be true with those two. I'll let you finish up this problem and start the next one. See if you can set it up. You don't need to name the theorem, but I'd like you to at least give a brief reason as to why you are setting up the equations you are. Again, pause the video and I will rejoin you in just a minute. When you start the video, the answers will show. All right, in these two examples, I found x to be 8 and y to be 30 in the first one. And that was where opposite angles are congruent. The next problem, we are using our theorem in parallelograms where opposite sides are congruent, then it must be a parallelogram. So if x equals 3 and y equals 7, this figure will be a parallelogram. Moving on to the last two examples. Sorry for the little jump in the video there. I want to move quickly through this example so we don't run out of time here. This example is a little trickier. We're actually going to prove that the opposite sides, one pair of opposite sides, are both congruent and parallel. If that's true, this will be a parallelogram. Well, the value for y would have to be where 3y plus 5 is equal to 7y minus 3. I'll let you solve for y. The trickier part of this is actually with the angles. I'm drawing a shape here. I hope maybe you recognize that backward Z shape. Those are alternate interior angles. And in the case of alternate interior angles, if 3x plus 4 is equal to 4x minus 2, those opposite sides will be parallel to each other. Go ahead, pause the video, try the last two examples on your own. When you unpause, I will show you the answer. Here's the answers to the last two problems. If you got the x and y wrong in the last problem, I would double check your distribution. Make sure that that is correct. That's the most common mistake on those. You may pause the video to check the work. I am actually going to move on to a quick announcement on the homework for tonight. There was a change. I've made it easier, so you want to hear this. It's 1 through 5 all, 9 through 14 all, 18 and 19. So you are skipping number 6, number 24, and number 26. If you watch the video tomorrow, at the beginning of the video, I will be showing you the solutions to this homework.